Welcome to Solving Quadratic Equations. The purpose of this video is to help you identify which strategy would be appropriate to use to solve a particular quadratic equation. In a previous video, I discussed 4 strategies for solving quadratic equations and when each is appropriate. These are the 4 strategies that I discussed. Let me say that there is always more than one way to solve a quadratic equation. Sometimes one strategy is much more efficient than another, and sometimes it's a matter of personal preference. I usually look at a problem and consider the strategies in the order in which they're listed here. So let's jump in and start practicing some problems. Let me move this up just a little bit. And here's our first example. The directions will just say solve. And it's up to us to figure out a good strategy to solve. The first one is 11x squared equals 14x. In looking at this particular problem, if you're not sure what to do, set the problem equal to 0. That is my backup plan always when I'm solving a quadratic equation, and then make a decision on what to do. So let's set it equal to 0. 11x squared minus 14x equals 0. Now at the top of the list, I have factoring as a strategy. The interesting thing about this problem is that often people forget about taking out the common factor and they end up solving the problem in a much less efficient way. So let's take out that common factor of x, and we're left with 11x minus 4 as our binomial. And as always, when we're solving a quadratic equation by factoring, we set each factor equal to 0 and solve. So I would have x equals 0. And this one we have 11x minus 14 equals 0. And you can solve that in your head. Add the 14, divide by 11. Totally fine to do those in one step. So we have x equals 14/11. So the 2 solutions for this problem are 0 and 14/11. Let me make 2 other comments about this problem. The first is this. If you have 11x squared equals 14x, a common mistake that people make is just to divide both sides by x. And you end up with 11x equals 14, so you have x equals 14/11. But notice we have lost the solution that is x equals 0. So in general, when we're solving an equation, we don't want to divide by any expression that contains a variable. You may be losing some solutions. The other thing I wanted to mention is the other way that's less efficient but still okay is to solve this equation by using the quadratic formula. The quadratic formula always works when solving a quadratic equation. So let's do it so that you can see why it might not be the best choice, but it still generates the correct answer. If we identify A, B, and C for this problem, we'll have A equals 11 because it's the coefficient of x squared. B is negative 14 as it's the coefficient of x, and C is 0 because we don't see a constant. So that means the constant was 0. So when we substitute those numbers into the quadratic formula, we have the opposite of B, so that's the opposite of negative 14, plus or minus the square root of a B squared minus 4 times A times C all over 2A. So I have x equals 14 plus or minus the square root of 196 minus 0, so that's just the square root of 196, all over 22. We continue and we have x equals 14 plus or minus 14 over 22, because the square root of 196 is 14. Let me scoot it up. See, I'm needing more space for this problem. It's longer than it was when we solved it by factoring. So we continue and we would have x equals 14 plus 14 over 22. That's 28 over 22. And 14 minus 14 over 22, which is 0 over 22. We simplify both of those and we have 14 elevenths and we have 0. And notice, in fact, we do have the same solution, which is what you expect. If the problem can be solved two different ways, we expect the solutions to still be the same. But I hope you see why factoring is probably the better way to go on this particular problem. Let's move to the next one. This time the problem will look like this. 2x squared minus x plus 9 equals 0. Since it's already set equal to 0, I can start considering the process for solving it. I consider factoring, and I always give factoring a try. So I'm going to set up my parentheses, and I try a 2x and an x. Let's see, 9. How about 3 and 3? No way does that give me a 1 in the middle. A negative 1 is what I'm shooting for. So I get rid of those 3's. Then I consider 9 and 1. Nope, that doesn't work. So then I'll try 1 and 9. Nope, that doesn't work. And I have exhausted the possibilities. But it's worth a try to me to see if factoring works. If it factors quickly, I'll use that strategy. If it doesn't, I move on. Using the square root property, let's see. The square root property gets used when the b is equal to 1, or excuse me, equal to 0. It's a negative 1 here, so the square root property doesn't apply. Completing the square, no, that doesn't look too good because my leading coefficient isn't 1. And if I were to divide by 2, I'd be introducing fractions. So completing the square, though it would work, isn't the most efficient way to solve this equation. So I'm down to using the quadratic formula. So let's identify a, b, and c. A is always the coefficient of your x squared, b is your coefficient of x, and c is the constant. And of course, that assumes that you have it set equal to 0. So we substitute those numbers into the quadratic formula, and we have x equals the opposite of b. So the opposite of negative 1 is positive 1, plus or minus the square root of b squared minus 4 times a times c, all over 2a. Now we do some simplifying. So we have x equals 1 plus or minus the square root of 1 minus 72. That is negative 71. So my radicand is negative 71. And I divide by 4. My last step is to simplify. There's not a whole lot to do, but I do have a negative number underneath that square root. That means I need to write it with an I instead. So I have x equals 1 plus or minus I times the square root of 71 all over 4. And this problem is complete. Let's move on to the next one. You'll notice this time I don't have the strategies listed on the page. That's because we need to have them mentally. Solving quadratic equations is very important, and we just need to know those strategies. So here's our next example. We're going to solve x plus 8 squared equals 12. Now, I told you I roll through those strategies in the order in which they were written, and factoring was listed first. But in order to factor it, I would need to multiply out the left-hand side, set it equal to 0, and spend time factoring. And I could do that, but let's think about the second strategy, which is the square root property. This is perfect for this square root property. The square root property says if we have this nice perfect square on one side and a number on the other side, we can just take the square root of both sides and efficiently get to my solution. I'm going to put my plus or minus in. Don't forget that when you take the square root of both sides. So I have x plus 8 on the left, and I have plus or minus the square root of 12 on the right. But the square root of 12 we know simplifies into 2 square root of 3. And then we subtract 8. So we would have negative 8 plus or minus 2 square root of 3. Now I will mention that even if we had multiplied it out and set it equal to 0, if we had tried to factor, this one would not have been factorable. And I can tell that because the answers, the solutions right here, are irrational. But you wouldn't know necessarily by looking at it unless you've practiced a bunch. Let's look at this next one. I like it because initially it looks very much the same as the one that we just did. It's x plus 8 squared equals 12x. Notice the huge difference, though. We don't have a constant on the right-hand side. So the square root property is not going to work for this one. So that means we are going to need to multiply the left-hand side out. So if we do that, we'll have x squared plus 16x plus 64, right? When you FOIL out that x plus 8 squared. And that will equal 12x. And now I'm going to set it equal to 0. So when we subtract 12x from both sides, we have x squared plus 4x plus 64 equals 0. And here we are. So again, I think about factoring. Is this one going to factor? And I can consider it for a moment. Never hurts. And I'm thinking about 64, it would factor into 1 times 64, or 2 times 32, or 4 times 16, or 8 times 8. And if you peek at those numbers, none of those pairs look likely to give me that 4 in the middle. So factoring is not going to be the way to go on this problem. So we'll just erase that. And on we go. Let's see. Factoring doesn't work. The square root property doesn't apply because my middle term exists. The coefficient here is not a 0, so we're not going to use the square root property. But think about completing the square. That was the third one on our list. And notice that our coefficient right here in front of the x squared is a 1, and my b is even. This is the perfect scenario for completing the square. So let's solve this one by completing the square. So I'm going to subtract 64. So I have x squared plus 4x equals negative 64. Remember, the goal is to get a perfect square on the left-hand side and have a constant on the right. So to determine the number that completes the square, I take half of 4 and square it. So half of 4 is 2. 2 squared is 4. So 4 is the number that completes the square. So let's add 4 on the left. And of course, that means we add 4 on the right. And because we chose the appropriate number, we'll have a perfect square, guaranteed. So we have x plus 2 squared equals negative 60. And now it looks a lot like the problem that's to the left. We use the square root property. Take the square root of both sides, putting our plus or minus in. On the left-hand side, we have x plus 2. On the right-hand side, we'll have plus or minus. Now we've got to do a little bit of work there. 60 is equal to 4 times 15. So we have a nice perfect square that we can take out. And notice also we have a negative number. So this will be 2i times the square root of 15. And we subtract 2. We have negative 2 plus or minus 2i square root of 15. And this problem is done. At this point right here, the other option would have been to use the quadratic formula. I prefer to use completing the square when the leading coefficient is 1 and the b is even. But you could use the quadratic formula and see which one you like best. This is one of those cases of it's really a personal preference. Let's try another one. Here's what it will look like. 2x minus 1 times x minus 3 equals 18. And at first, people are happy seeing the factorization on the left-hand side, but that's not helpful at all unless we have a 0 on the right-hand side. So in fact, I wish it weren't factored. So our first step, oh, I didn't even write the directions for this example, and the directions are, of course, solve. We're going to need to multiply out the left-hand side. So when you FOIL these two binomials together, we'll have 2x squared. We have a negative 6x on the outside and a negative 1x on the inside. That's negative 7x plus 3, and that will equal 18. Now let's set it equal to 0. So we have 2x squared minus 7x minus 15 equals 0. I will tell you that frequently I have people just ignore factoring as a strategy and grab the quadratic formula, especially when they see a coefficient of 2 up here. But don't let that stop you. You want to be good at factoring. You want to practice factoring, especially when the numbers are friendly, as they are in this case. So let's try. I'm going to set up my two sets of parentheses. And we have 2x and x. 15 is 1 times 15 or 3 times 5, right? And we're going to try 1 and 15. Nope, that doesn't give me the 7 in the middle. So I'd try 15 and 1. Nope, that doesn't do it. So let me erase that. And so that's not it. That 1 and 15. I'll try 3 and 5. So I put a 3 here and a 5 here. Oh, that looks good. We have a 10x on the outside and a 3x on the inside. So if I make a negative here and a positive here, it factors. So our solutions come from each factor. 2x plus 3 gets set equal to 0. And if you solve that, you will find that x equals negative 3/2. Completely okay to just go to the solution from here. X minus 5 equals 0 means that x equals 5. You're finding the number that makes each of those individual factors equal to 0. And this one is complete. There are two other ways you could solve this problem. I think this factorization is the most efficient. But the other ways you could do this problem are right from this line. You could have completed the square. You would have to divide by 2 first and work with fractions. It is doable. I think it would be pretty cumbersome to get there. But the other way is using the quadratic formula. Let's do another one. The problem we're going to solve this time will be 11 equals 6x squared minus 2. What I hope you notice about the problem is that there is no x to the first power in it. That means b is equal to 0. The coefficient of x is 0. If you see that, this is the time to use the square root property. I know I told you I sort of roll through those strategies in the list, in the order in which I had listed them. But if I see that I don't have an x to the first power, I go right to the square root property. So I add 2. I divide by 6. And I'll take the square root of both sides. And by the way, if it bugs you to have the x squared on the right-hand side, put it on the left-hand side. Sometimes that does bother people. It doesn't particularly bother me, but if it bothers you, switch it. If it doesn't bother you, don't take the time to do that. Now I'm going to take the square root of both sides. I put my plus or minus in front. So I have x equals plus or minus the square root of 13 over 6. And last, let's just take the time to rationalize the denominator. So I'm going to multiply by square root of 6 over square root of 6. So I'll have a nice rational denominator for this one. So I have plus or minus the square root of 6 times 13, which is 78, over 6. And we have it complete. What if you didn't notice that the b was 0? You know, you didn't even see it. Let's come back here to the beginning. It's 11 equals 6x squared minus 2. My backup plan always when solving a quadratic equation, if I'm not sure what to do, is to set it equal to 0. So if you didn't notice that the square root property was the way to go on this one, subtract 11 and take another look at the problem. So you would have 0 equals 6x squared minus 13. And now maybe at this point you see that the square root property would be the way to go. But what if you didn't? Well, factoring doesn't work and completing this square doesn't apply. But quadratic formula always works, so you could identify your A, B, and C. A is 6. B is the coefficient of x, which I've mentioned is 0, because we don't see the x. And C would be negative 13. And you could throw those numbers into the quadratic formula and do some simplifying. I will say the way on the left will be much more efficient from my perspective. But go ahead and try using the quadratic formula. I'm not going to take the time to, but if you prefer to, go ahead. Let's do one last problem. And it will be this. Solve 4x times the quantity x plus 1 minus 7 times the quantity 2x minus 1 equals 2. And at this point, I certainly don't know what strategy I would be looking to use. I need to multiply it out, maybe set it equal to 0, and take another look. So let's distribute the 4x, and we have 4x squared plus 4x. Then distribute the negative 7. Minus 14x plus 7 equals 2. Let's simplify. So we have 4x squared minus 10x plus 7 equals 2. Set it equal to 0. 4x squared minus 10x plus 5 equals 0. And here we are. Now let's try factoring. I'm starting at the top. See what I can do. Set up my parentheses. I'm going to try 2x and 2x first. Quickly, I pop in a 1 and a 5, and I see right away there's no way to get a 10 in the middle that way. Switching 5 and 1 doesn't matter at all because the coefficients up front were the same, a 2x and a 2x. So that didn't work. So let's try 4x and 1x quickly. So I have 4x and x, 1 and 5, nope. 5 and 1, Nope. So that didn't work. I've run out of things to try. So let me erase my factoring. But I don't consider that a waste of time. You get pretty proficient at factoring, and you can start to identify pretty quickly whether something is going to be factorable or not. So factoring didn't work. I look and see that the b is not equal to 0, so this one is not a square root property problem. Now my leading coefficient here is not a 1, so if I were going to complete the square, I'd have to divide by 4 first, and that would introduce a couple of fractions into the problem, so I'm not going to do that. So that brings me to quadratic formula. So here we go. A equals 4, B equals -10, C equals 5. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And now we have some simplifying to do. The radicand, I'm over here on scratch paper, is -10 squared minus 4 times 4 times 5. So that's 100 minus, let's see, what is that, 80? So that's 20. So I have 10 plus or minus the square root of 20 over 8. I don't have a visible common factor yet because my coefficient right here is a 1. Notice what I'm looking at, looking for a common factor. I see a 10, a 1, and an 8. So I don't have a common factor visible yet, but I'm going to simplify the square root of 20. So we get x equals 10 plus or minus 2 square root of 5 over 8. Now look at those coefficients, or excuse me, those constants. We have 10, a 2, and an 8. We do have a common factor this time, so we can cancel off the common factor of 2, and we'll have x equals 5 plus or minus 1. I don't need to write the 1. Square root of 5 over 4. And this problem is complete. I hope you'll go practice solving some quadratic equations.